Hi class. Let's look at the application of sensible heat and latent heat to weather. First, we're going to take a look at the application of sensible heat. So we've got this figure here. You're going to look at this as we're drawing it and go, haven't we already drawn this figure? Yeah, we have. And we're just going to add a little bit to this figure. And we're going to continue to add a little bit to this figure throughout the semester. And so we've got the sun, okay, and we got the top of the Earth's atmosphere, and the sun is shining down, okay, as we've mentioned many times before. That's 7% ultraviolet radiation, 43% visible radiation, 49% infrared radiation. As the sun passes through the Earth's atmosphere, three things can happen to it. It can be reflected. That was 24% is reflected on a global basis, 7% is scattered on a global basis, and 20% is absorbed by the atmosphere on a global basis. And so let's just bring it all the way down to the surface. Something else you might look at is like, oh, I haven't seen that before, so that's new. So I got a little tree here. I got some corn plants to represent crops. I've got a little lake here to represent a water surface. This will come in when we talk about the application of latent heat to weather, okay? And so first we're talking about the application of sensible heat. So we've got solar radiation coming in, and again on a global basis, that is 49% makes it to the Earth's surface. So 49% of incoming solar radiation is absorbed by the surface. Alrighty, so 49% is absorbed by the surface, and of course what that is going to do, that's going to cause the surface to warm. So whenever any object, the Earth's surface, absorbs any form of radiation, ultraviolet, visible, or infrared, the object, the Earth's surface, is going to warm up. So this is going to cause the surface to heat up or to warm. Okay, and we'll represent that by, we've done this before, little red dots to represent heat energy being absorbed by the Earth's surface. Okay, so there's our red dots. All right, so when the Earth's surface warms up because it's absorbed in incoming solar radiation, that's going to establish a temperature gradient. Okay, a temperature gradient between the Earth's surface and the air above, and the Earth's surface and the ground below. So again, a gradient is a change in a property over a distance, and so here we're talking the property is temperature or heat energy, and there's a gradient of heat energy between the surface and the air above and the ground below. Whenever there is a temperature gradient that's established, there's going to be a transfer of heat energy. So we'll make that note. So there will be a transfer of heat energy. And again, you know this, we've drawn this figure exactly the same as we have before. Nothing's different. And we're just going to add that. And so that transfer of heat energy in this particular case is going to be through conduction. Okay, so heat flows from an area of surplus to an area of deficit. So the heat will flow up into the atmosphere above, into a thin layer of air that's in contact with the ground, and into the ground below. All right, and remember we call that conduction. Let's see if I can draw this in here. So CO, conduction. All right, so we got conduction taking place. And let's make sure that we know that this is in a thin layer of air. That's in contact with the ground. All right, so when we conduct that heat energy from the surface into the thin layer of air that's in contact with the ground, okay, this is going to warm up the air. So this warms the air, okay, via conduction, via the conduction of the heat energy from the surface into that thin layer of air. Okay, and this is going to reduce the density and the air rises because of the reduction in air density. Okay, and so that air is going to rise through convection. Again, it's like, man, we've drawn this exact same figure again. We have, okay? And we're going to add to it in just a little bit, okay? And so in this particular case now we've got conduction and we've got convection. And for those of you who do like math, what we could do is off to the side here, we can write a little math equation, and we can write conduction plus convection equals sensible heat. Okay. Now remember, we got to go back to that figure we just talked about, that one with all the arrows on it. Okay, so remember in that figure we had a surplus of radiational heat energy at the Earth's surface. We had a deficit of radiational heat energy in the atmosphere of 30 units. So on a global basis, we have to move that surplus heat energy from the surface up into the atmosphere. Okay, one of the ways that we do that is through sensible heat. Okay, so the Earth's surface heats, it warms that thin layer of air that's in contact with the ground, and that reduces the density of the air, so the air rises through convection, and it carries heat energy with it from the surface, where there's a surplus, into the atmosphere, where there's a deficit. Okay, so so this is one of the ways. Okay, so we got to move 30 units of heat energy, surplus heat energy from the surface up into the atmosphere, where there's a 30 unit deficit. Okay, so one of the ways we do that is through sensible heat, conduction plus convection, and that's going to move a total of 7 units out of that 30 units surplus from the surface into the atmosphere. Okay, so next, what we're going to do is we're going to take a look at latent heat. So I'm going to come back to this same figure, and I'm going to add a little bit to it when we talk about latent heat. Okay, so that's coming up.